Hello and welcome to The Space Above Us. Episode 11, X-15, Flight 91. Last time, we introduced the experimental hypersonic rocket plane known as the X-15 and followed along as it pierced the Karman Line and entered space on its 90th flight. Today, we will be discussing the nearly identical 91st flight while also trying to cram in a lot more information about the X-15 before we set this remarkable aircraft aside and move on to Project Gemini. The first thing I'd like to do is introduce the complete list of X-15 pilots. We already know Joe Walker from last time's episode, and spoiler alert, he's about to fly this next spaceflight of the X-15 as well, but what about the other 11? The one who started it all was Scott Crossfield, who served as the test pilot for the vehicle's manufacturer, North American Aviation. Crossfield never flew particularly high or fast, at least by X-15 standards, but he flew the always dangerous early flights, learning how the aircraft flew, what surprises it had in store for the pilots and engineers, and how to fly it safely. Next were 5 pilots representing the United States Air Force. In alphabetical order by last name, Michael Adams, the only pilot to be killed during the X-15 program, but I'll talk about that in a second. Joe Engle, who went on to fly the space shuttle, so we'll see him again a little down the road. Pete Knight, Bob Rushworth, and Bob White. Representing the other major partner in the X-15, NASA, was an additional 5 pilots. Again, in alphabetical order, first was a guy you may have heard of named Neil Armstrong, who specialized in the advanced automatic control flights. Then Bill Dana, John McKay, Milt Thompson, and hey, Joe Walker snuck back in here. Rounding out the list was the lone representative from the U.S. Navy, Forrest Peterson. These are some serious aviation heavy hitters, and there is more of an overlap with the world of spaceflight than you might think at first. Neil Armstrong obviously stands out to us today, and Joe Engle went on to become a space shuttle commander. In addition to that, several of the pilots were chosen to fly on board the Manned Orbital Laboratory. The MOL was a manned military reconnaissance satellite that never quite left the drawing board, and that I hope to talk about in a future supplemental. Still more pilots, including some from the MOL group, were chosen to fly the X-20, otherwise known by its ridiculous name Dyna-Soar, short for Dynamic Soarer, which would have been a sort of mini space shuttle. The plan was to launch it vertically on top of an expendable rocket, and then land horizontally on a runway. Actually, its size and launch method on top of a rocket instead of strapped onto the side of it like the shuttle remind me a lot of the modern-day Dream Chaser spacecraft, which should begin delivering cargo to the ISS in a few years. Sadly, the Dyna-Soar was cancelled due to budget concerns, and presumably meteorites. We had to wait another 15 years to see wings in orbit. But the most direct connection to space for these pilots is what I'd like to talk about next. The 11 flights that flew higher than 50 miles, but lower than 100 kilometers. As I've discussed ad nauseum, the internationally recognized boundary to space is the 100-kilometer Karman Line. I think I've also mentioned this before, but the line is defined as the altitude where you would have to fly so fast to maintain lift with any wings that you'd already be at orbital velocity anyway. That said, the edge of space is still a pretty arbitrary line. Since these things were new and nobody got together to agree on this, the U.S. Air Force settled on 50 miles, or 84.7 kilometers, as the official edge of space. So, going by that metric, our list of 1960s astronauts grows to include Michael Adams, Bill Dana, Joe Engle, Pete Knight, John McKay, Bob Rushworth, and Bob White. Before learning about the X-15, my attitude towards these high, but not quite high enough, flights was along the lines of, that's too bad, should have tried harder. In my mind, the 100-kilometer limit was inviolable, but I must admit that I've gained some sympathy for these guys. 50 miles, and really much lower than that, is for all intents and purposes space. You need a space suit, a reaction control system, a plan for re-entry, all that stuff. It's basically space. So, while I still like using the Karman Line as my official edge of space, I'm inclined to count these guys as full-fledged astronauts. Who's with me? Alright, since I know you're all interested, let's talk about Michael Adams. Michael Adams was a U.S. Air Force test pilot who had flown the X-15 6 times before his fatal accident on Flight 191, shortly before the termination of the program after Flight 199. Flight 191 was a high-altitude flight that topped out at 50.3 miles. While coasting up towards apogee, something happened, and the X-15 drifted 15 degrees to the right. Telemetry then indicated that the pilot turned even further to the right. No one is really sure what happened, but it's probable that the pilot was distracted by some minor problems, was likely suffering vertigo due to the extreme changes in acceleration, and may have become confused in the process. It's easy, in comfort on the ground, to be surprised that an experienced pilot could allow something like this to happen, but it's important to realize just how complex and disorienting these extremely short flights could be. The vehicle re-entered the Earth's atmosphere completely perpendicular to the direction of travel, entered a hypersonic spin, and disintegrated over the desert. The pilot did not eject and likely was incapacitated by the high G-load and lost consciousness before the final breakup. The loss of both Adams and X-15 No. 3 was a tragedy and played a significant role in the program being wrapped up just over a year later. It also serves as a sober reminder that in spaceflight and high-powered aviation, it is easy for a small problem to rapidly snowball out of the control of even the best pilots in the world. Today, Michael Adams is remembered on the Space Mirror Memorial at the Kennedy Space Center Visitors Complex, alongside many other brave individuals who gave their lives pursuing the dream of spaceflight. We should probably talk about the real topic of this episode, the 91st flight of the X-15. This is sort of unusual, but I'm not really sure what to say about Flight 91. I could walk you through all the specifics like I did last time, but the flight really was a carbon copy of Flight 90. It's not even like Freedom 7 versus Liberty Bell 7, where at least they had a new pilot and a few tweaks to the vehicle. Since this was such a high-altitude flight, they had to use X-15 No. 3, which was equipped with the automatic control system for use in space. And as far as I know, no changes were made to the vehicle in the lone month between flights. So, let's just do this. On August 22nd, 1963, just 34 days after his previous flight, Joe Walker flew X-15 No. 3 to a record-setting 67 miles, or 107.8 kilometers, in altitude, before safely landing on the dry lake bed at the Edwards Air Force Base. Ta-da! That's it. So there may not have been much for me to say about the flight itself, but at least it gave me a great excuse to talk about the X-15 for one more episode. Before we turn the page on the X-15, I have one more thing to say on the topic. I've been trying to think of a good way to really hit home just how impactful the X-15 program was, and I think I found something good. If you'll humor me for a minute, I'd like to read this incredible list of X-15 achievements that I have shamelessly taken from a NASA website, specifically the NASA Armstrong Flight Center fact sheet on the X-15. Alright, here we go. This is all one big quote. The distinguished Langley aeronautical researcher John Becker, who had been an early advocate of the X-15 program, identified 25 specific accomplishments of the effort. These included first application of hypersonic theory and wind tunnel work to an actual flight vehicle. First use of reaction controls for attitude control in space. Well, space-like environment, maybe, for first. First reusable superalloy structure capable of withstanding the temperatures and thermal gradients of hypersonic reentry. Development of a servo-actuated ball nose flow direction sensor for operation over an extreme range of dynamic pressure and a stagnation air temperature of 1900 degrees Fahrenheit for accurate measurement of airspeed and flow angle at supersonic and hypersonic speeds. Development of the first practical full pressure suit for pilot protection in space. Development of inertial flight data systems capable of functioning in a high dynamic pressure and space environment. Discovery that hypersonic boundary layer flow is turbulent and not laminar. Discovery that turbulent heating rates are significantly lower than had been predicted by theory. First direct measurement of hypersonic aircraft skin friction and discovery that skin friction is lower than had been predicted. Discovery of hotspots generated by surface irregularities. Discovery of methods to correlate base drag measurements with tunnel test results so as to correct wind tunnel data, and thereby improve design criteria for future air and spacecraft. Demonstration of a pilot's ability to control a rocket-boosted aerospace vehicle through atmospheric exit. Successful transition from aerodynamic controls to reaction controls and back again. First application of energy management techniques. Use of the 3 X-15 aircraft as testbeds to carry a wide variety of experimental packages. Holy crap. That wasn't on the NASA website, by the way. That last one was just me. That is one impressive list of accomplishments. I hope this episode and the last inspire you to go out and learn more about the development and operations of the X-15. 2 books I found particularly helpful were X-15 Reaching for Space, which was written by a bunch of people but compiled by Jonathan Clark, and At the Edge of Space by Milton Thompson, a former X-15 pilot himself. The latter is a little more approachable, so you might want to take a look at that first. Well, that's it. It looks like we have successfully managed our gliding energy and come in for a perfect touchdown in the Californian desert. It's time to hurry back over to Florida's East Coast and resume our regularly scheduled spaceflight history. So join me in 2 weeks for an introduction to NASA's next manned orbital program, the program that would prove to be the all-important training ground for the moonshots to come while still maintaining an identity of its own, the program that would introduce a new cast of astronauts, new milestones, new techniques, and new vehicles. The one and only Project Gemini. It's been a while since I've given out my contact information on the show, and I can see by these charts that I have that we have a few new listeners. Please feel free to send any comments, questions, or really any feedback in general to me via email at jp@thespaceabove.us. That's jp@thespaceabove.us. You can also get a hold of me via Twitter at the username @SpaceAboveUs. I dropped the to save a few characters. We also have a Facebook page that I must admit I'm pretty negligent of, facebook.com/thespaceaboveus. While I'm talking show details like this, I'd like to once again say a sincere thank you for listening. I really enjoy researching and making the show, but it's great knowing that other people are interested enough to listen. If you're enjoying the show, please do me a favor and tell any friends you think might like it as well. It also helps a lot if you rate and review me on iTunes or Google Play or whatever. It almost feels cliche these days to say subscribe and review, but it really does help. Alright, that's enough show-related stuff. This is the part where I say, Ad Astra, catch you on the next pass.